All right, this is it, your final prep session for the ICSE Class 10 physics paper. We're going to distill everything down to the absolute essentials, the things you have got to know to nail this exam. This is your final guru mantra.
Okay, let's just cut to the chase. Forget the stress, forget the last-minute panic. I want you to think of this as your secret roadmap. We're going to focus your energy only on the topics that are practically guaranteed to be on your exam. First up, we've got the chapter on force. But look, we're not going to get bogged down in everything. We are zeroing in on the part that really matters for your score, the turning effect. You know it as torque.
You know, it's funny. This is something you do every single day without even thinking about it. I mean, why is the handle on a door always at the edge, as far away from the hinges as possible? It's not a random design choice. It's pure physics. You are instinctively using torque to your advantage.
And here's where it all clicks into place. The formula is simple. Torque is just the force you apply multiplied by the perpendicular distance from the pivot. That's why a mechanic grabs a long wrench for a stubborn nut. A longer handle means more distance, so they need less muscle to get the same turning effect. It's physics making life easier. Now, for your numerical problems, this is absolutely crucial. It's a super simple rule, but you have to lock it in. If something is rotating anti-clockwise, its moment is positive. If it's going clockwise, it's negative. Don't get these mixed up. It's an easy place to lose marks.
All right, let's keep the momentum going. Our next guaranteed topic, and I mean, you can pretty much bet there'll be a numerical question on this, is the center of gravity.
Look, don't get lost in the deep theory here. What you really need to know, what they're actually going to test you on, are the specific locations of the center of gravity for a few common shapes.
Yeah, this one is just straight-up memorization, but trust me, this is where you can grab some easy marks or lose them if you're not careful. Pay really close attention to the cones. That little difference between h/4 for a solid cone and h/3 for a hollow one, that's a classic exam question designed to catch you out.
Okay, let's talk work, energy, and power. We're going to skip the basic definitions you've known for ages and jump right into the concepts that can be a little tricky, the ones that pop up as those application-style questions.
Okay, hold on. Let's really think about this for a second. It sounds completely wrong, doesn't it? You push something, it moves, but the work you did was negative? How on earth is that even possible?
Well, it happens anytime the force you're applying is in the opposite direction of the actual movement. Think about drawing a bow. You pull the string backwards, right? But the arrow is going to shoot forwards. Your force is backward, but the displacement is forward. That right there is negative work.
All right, quick one here, but absolutely vital. 1 joule is 10 to the power of 7 ergs. Just memorize it. No tricks, no concepts, just a fact you need to have in your back pocket for calculations. And for power, here's the other big conversion to burn into your brain, especially when you see questions about engines or machines. 1 horsepower is 746 watts. Simple as that.
Okay, this brings us to one of the most powerful and honestly beautiful ideas in all of physics. And the easiest way to understand it is with the simple story of a falling ball. So picture this. You're holding a ball way up high, just before you let it go. At that exact moment, it's packed with potential energy, right? But it's not moving, so its kinetic energy is 0. The total energy it has is just mgh. Now, you drop it. As it falls, something incredible happens. That potential energy it had stored up starts converting into kinetic energy. It's losing height, but it's gaining speed. But here's the cool part. If you add up the potential and kinetic energy at any point during its fall, the total is always the same. It's still mgh.
And then, in that split second right before it hits the ground, the transformation is complete. All of that potential energy from the top is now kinetic energy. The ball is moving at its absolute fastest. And the total energy, you guessed it, still mgh. Energy wasn't created or destroyed, it just changed form. Look, the chapter on light is huge, right? We can't cover all of it right now. But there are 2 fundamental rules of refraction, how light bends, that you just have to know. No excuses. It's actually really simple. When light goes from a rarer to a denser medium, like from air into water, it bends towards the normal. And when it goes from denser to rarer, like water back into air, it bends away from the normal. Just remember those little mnemonics, RDT and DRA. They're lifesavers. So what's the big takeaway from all of this? The real guru mantra? It's to stop trying to cram everything at the last minute. Focus your energy. If you can master these core concepts we just covered, you will be in fantastic shape for your exam.
Hey, if this rapid-fire review helped you out, then you know what to do. These slides came from the Study Slides YouTube channel, so definitely go check them out for more explainers like this. Now go ace that exam. Good luck!